The beauty of PMBOK related topics are that all the topics are interrelated, and we cannot really start or jump into a topic directly without giving you a quick background of that particular topic. So the topic that we have selected for today's webinar is the scheduling techniques, and I would need to give you a brief background of why this scheduling technique is important, where exactly it is placed, and how exactly it's related to other project management related processes. To start with, guys, can somebody tell me what do you mean by a project management process? Repeat my question. What is the definition of a project management process? You can use the question panel to answer your question, or you can raise your hand and I can quickly unmute you so that we can communicate with each other. Any idea? My question is, what is the definition of project management process? Okay, have an answer from activities, tasks. That is very correct. Let me elaborate a little bit. The PMI doesn't use the term activity or task when it comes to project management related work or project management related activities or tasks. So they rather use the term process. So when we say process, we are not really pointing out to some some standard guidelines or regulations. Project management process simply indicates to project management tasks or activities which are required to be performed in order to complete the project end to end, or rather we can say which are required to complete the project deliverables. For example, in this particular on your screen right now, starting from here in the lighter part of the table, starting from 4.1 till 13.4, all the topics you see are project management processes. In other words, these are project management tasks or activities that a project management team needs to perform in order to complete the project-related deliverables. For instance, we have a develop project charter. That's a project management activity that's mainly the responsibility of the sponsor or the customer when they create a very initial document to recognize the existence of the project. Similarly, create WBS or develop schedule, determine budget. These are all project management processes. For our ease of understanding, these processes are segregated into 5 process groups, which you can see in the first row of this table. So depending on what stage of project management life cycle do we perform these processes, we have these 5 process groups. Okay, for example, develop project charter and identify stakeholder, they are performed or they are done during the very initial stage of project management life cycle, even before the planning starts. So they are part of the initiation process group. Similarly, we have planning process group, execution process group, monitoring and controlling process group, and closer process group. I repeat, these classifications of process groups are based on which stage of project management life cycle do we perform these processes. At the same time, we have 10 knowledge areas, as you see in the first green column in this particular table. These are the classification of project management processes depending on the area of concern, or we can say the focus area of the project management team. For example, what all do we do in order to manage project scope? Would be part of project scope management knowledge area. What all activities are involved in management of project quality? Those would be part of project quality management knowledge area, and so on. Having said that, we can say that any process is part of a particular process group and also part of a knowledge area at the same time. Like develop project charter is not only part of initiation process group but also part of integration management knowledge area. So this is just to explain the background of how the processes are aligned in project management as per PMBOK 5.0. I have somebody raising his hand. Let me quickly check. Okay, that hand just went away. So maybe that was by mistake. No worries. Okay, now coming to today's topic, guys, that how and when do we do the scheduling? In order to explain that, we need to quickly talk about the WBS. WBS stands for Work Breakdown Structure. We have a process, create WBS, as part of Scope Management Knowledge Area. The objective is to break down the project scope into smaller work packages or smaller components of work packages, okay, which are easily manageable, and we can control the project easily based on those work packages. So, in other words, we can say that the WBS breaks down the entire project scope into small work components which are easily manageable, and we can do all the estimations, scheduling, planning, controlling, etc. not ad hoc on the entire project scope, but rather on the smaller work components. So it makes project management very easy. Okay. To answer the question from Nicole, yes, you would get the copy of the slides, and you'll also get the recording of this webinar. Just drop a mail to support@wizlabs.com in case you need it. Okay. Now, having talked about the WBS, if I ask you, we said that the WBS is a kind of a pictorial view, looks like an org chart or a fishbone diagram that breaks down the project scope into small work components. So if I ask you a question, what is the limitation of WBS? What is that the WBS does not show? Can somebody answer? It shows the hierarchy of all the work components, how the deliverables are broken into sub-deliverables and sub-to-sub-deliverables. It also shows, with the help of WBS dictionary, that who is primary responsible, secondary responsible, what are the activities involved, etc., related to the work packages. But what is the limitation of WBS? What exactly the WBS does not show? Time that is required to complete the task. WBS do not show the timelines of the each task. That's correct answer. But again, WBS is from scope point of view, and timelines are from schedule point of view. If I refine my question, from scope point of view, what is that the WBS does not show? The answer is WBS does not show the interdependency between the activities, or it does not show the relationship between the activities. I mean, in what sequence we should complete the work packages, that is not part of the. I have a complaint from Ibrahim regarding the sound quality. Has everybody any issue? All of you have issues with the sound quality? Audio quality is poor. Is it with everybody? Could you allow me just a quick moment to check it? Should be all right. Is it better? Can you hear me fine now? Is it all right? Or you still have issues with audio quality? Is it still low? Is it better, guys? Can you hear me perfectly all right? Okay. I hope the audio quality increased, yeah? Thank you so much. And sorry about that. I just made a small change on my mic. It's sometimes not very good with the gadgets. I'm sorry. But again, let's come back to the topic quickly. What we were saying before this interruption was we what is the limitation of the work of the WBS, the work breakdown structure, and I from scope point of view, and I said the answer is the WBS does not show the interdependency between the activities, does not show the relationship between the activities. I mean, which should be done first, which should be done next, etc. When that is done, how exactly do we do the scheduling part? That is part of project schedule management or project time management knowledge area. In project time management knowledge area, we have a process to sequence the activities. Here, if we actually take the inputs from WBS itself. So the create WBS process gives me an output, that's work breakdown structure, in which I have all the work packages given in a pictorial view. We would use the work packages or even the activities within the work packages. We would determine the dependencies between the activities, and we would put them in a proper sequence with the help of network diagrams. Why that sequence is required? Because we need to understand what would be the complete time duration of the project. Even if we find out the total time duration of individual activities, without understanding the sequence of the activities in which they need to be performed, we cannot find out the complete schedule of a project. That's why sequencing activities are important, and we take help of network diagrams to do that. Let's see how exactly it happens. First of all, in order to understand that, we need to understand the relationship between the various activities, how they are, how they go, and what are the various relationships we have between various activities. On your screen, we are talking about 4 different relationships that 2 activities might have in between themselves. The first one, and the most common of the lot, is finish to start activity, wherein, let's say, activity B can be started only after activity A has been completed. This is an example of finish to start relationship. For example, you can start planting the trees only after you have completed digging the holes. You can start painting the walls only after you have completed the plastering work. So that's a finish to start relationship. You cannot do it the other way around. You cannot do 2 works parallelly. You have to complete one work, and then only you can start the next one. Start to finish, we can start activity, we can finish activity B only when we have started activity A. Okay, so that's a start to finish relationship. A bit rare. You would not get too many examples in the real world. If you can think of some example, please put it on the question panel. Start to start relationship, wherein I can start activity B only when I have started activity A. For example, I can start the coding only after I have started the design. It's not mandatory for me to complete the design before I start the coding, but I definitely have to start the design at least in order to ensure that I can start the coding work. That's a start to start relationship. And the fourth one is finish to finish. You can finish activity B only after you have finished activity A. For example, you can finish a project only when you have finished the documentation. Administrative closure is not complete without the documentation of project reports, right? So we can say a project is completed only when the documentation is completed. That's an example of finish to finish relationship. Now, these were for just the explanation purpose, and just to let you know that We have different type of relationship between activities. From exam point of view, you need to concentrate only on finish to start relationship. This is the most important and most commonly found relationship between two activities. And when you draw the network diagrams, the scheduling techniques that you apply on project activities, you actually use a finish to start relationship. So this is something that you need to keep in mind from exam point of view. Now, how exactly do we create a network diagram? How exactly do we start working on the project schedule? That's the point of discussion here. In order to explain that, we'll quickly take a look at the bookish definition, but it would not be clear until we take a look into a real example. We use a precedence diagrammic method. It's also called activity on node diagrammic method. Pretty simple. We would use boxes or nodes to represent activities, just like you saw in the previous diagram, and we would use arrows to show the dependency between activities. That's an example of precedence diagrammic method, or it's also called activity on node diagrammic method. When we talk about the relationships, there can be a mandatory dependency, a hard logic that you got to do it that way. Like the example I gave you, that you cannot start planting the trees before you have dug the hole. You have to complete the foundation of a building, then only you can start the construction work. So those are mandatory dependencies or hard logic. There can be a discretionary dependencies. I simply prefer to do it that way even though it's not mandatory. For example, I simply prefer to complete the interior decoration of the building before I start the exterior decoration work. It's not mandatory for me to do so, but it's just that I prefer doing it that way. And external dependency, wherein you have an external rule that you have to do it this way. For example, once the design is complete, you have to take an approval from an government authority to get the design approved before you start the construction work. That's an example of external dependency. Two more things you need to keep in mind from scheduling point of view. Leads. Leads are applied to remove time. That means, for example, we originally planned to do activity A and B in sequence. If I want to do activity A and B in parallel, so I'm removing time from the start time of activity B, or in other words, I'm bringing activity B closer to the project start time. This is an example of applying lead, wherein I'm bringing a particular activity closer to the project start time. Okay? Lag is just the reverse, wherein we talk about putting an wait time. For example, we would start activity B after the completion of activity A, but we will also have a lag of 2 weeks. Let's say after you have completed the plastering work, you have to wait for 2 weeks to allow the plastering to settle down. Then only you can start the painting work. That is applying lag. You are actually putting a wait time between two activities. Any question, guys? Is it all clear? So far, we just talked about the definition and we would move to an example as well. But as of now, any question? Okay. How exactly do we do the scheduling? Having understood this, dependencies, leads, lags, and the diagrammic method, how do we do the scheduling, and then how exactly do we find out the total duration of a project? The method is called a critical path method. If you look into the bookish definition given on my screen right now, this is a bit confusing actually, because it's a bookish definition. It's using I would say a complex way to define critical path. If I simply define critical path, I would say we would find out how many paths we have in a project schedule network diagram, how many ways we can reach the project end date from the start date, and we would find out the path which has the longest duration. With the help of this method, we would be able to find out which path has the longest duration and which path actually indicates the total duration of the project. That is the gist of critical path method. While doing so, we do not calculate the resource constraint. We simply concentrate on the dependencies or the relationship between the activities, and that's the only way we find out the network schedule diagrams. Let's take up an example to understand this in a better way, and the definition would be clear only when we look into an example of this diagrammic method. Let's see. We have a concept of float or slack, but we'll skip this topic as of now. We would actually get directly to an example, and we'll come back to this at a later stage. See, look into the table right now. We have an example wherein we are talking about various activities in this particular column. We have the activity description in this column. We have the immediate predecessor activities in this column. We have the duration in this column. We would not look into the resource constraint at this point of time because we are simply following the critical path method without accounting for the resource constraint. We would simply concentrate on one variable, that is the duration of these activities. Now, if you notice, if you actually look into this table given here, can you identify the process or can you identify the activity which does not have any immediate predecessor activity? Immediate predecessor means which activity happens just before that activity. Yep. Which activity does not have any immediate predecessor activity? That is activity A. So we can say that A is the first activity to start the project, right? As A does not have any immediate predecessor activity, in other words, no activity is happening before activity A, we can say that the project starts with activity A. Simple. Then activity A would be the first process or first activity in this network diagram. We said that we represent it with a box that's or a node. So this is how we would represent activity A. Now quickly find out which activity or activities have A as its immediate predecessor activity. I can see that activity B and activity E both have A as its immediate predecessor activity. That means B and E would happen immediately after activity A. So we can draw two arrows from activity A. We can have activity B in a box like this, and we can have activity E in a box like this. Guys, is it difficult to understand? This is how you can draw the network diagram to project the schedule of a project, to plot the schedule of a project. I repeat quickly, I first found which is the activity that does not have any immediate predecessor activity, and then I found which are the activities that have A as its immediate predecessor activity. And that way, the next step would be to find out which activities have B as its immediate predecessor activity and continue this way. When you continue this way, you would actually be able to draw a network diagram, something very similar to this. right? So if you follow the method I described in the previous slide and you keep drawing the network diagram, see, I'm using the term network diagram doesn't mean that it contains some routers, switches, or some network elements. It just contains the boxes and the arrows to show the project schedule, how it should be from the start to till the end of the project. That's it. Easy to understand up to this much, guys? Any questions so far? Now, if I ask you, I am not actually getting confirmation from all of you. I just have a couple of people participating in the conversation or in the question panel. It is actually good if you participate. If you have any question, you do not have to wait till the end of the session. You can simply ask me the question. Okay, I have a question from Nicole. Is the spatial difference between the boxes determined by time? No, no, no. Sorry, that was my bad drawing, you can say. The time duration is given inside the boxes. Okay, we are considering that there is no time gap between A and B. The arrow does not represent time at all. It does not represent time. Okay, the numbers inside the boxes represent the time duration. Okay, so A has a duration of 4 weeks, B has a duration of 4 weeks, C has a duration of 4 weeks, E has a duration of 6 weeks, and so on. And the arrows are just showing the relationship between the activities, no other significance. Clear, Nico? Now, if I ask you, this is how my project is supposed to be happening. That we start with activity A, then we have activity B and E happening parallelly. We have C, F, and G happening parallelly till the end of the project. And by the end of the project, just to close this diagram, we have a dummy node. You can consider this as a dummy node end with 0 duration. Okay, so this is how my network diagram would look like. I have somebody raising his hand. Let me see, who is it? As soon as I try to find out who is that person actually drops his hand. If you have a question, do not shy away. We can unmute you and we can interact. No worries. Okay, moving ahead. Now, question to you. Can we find out the paths we have in this network diagram? Paths means from start to end, how many ways you can actually follow. I can see a path from A to B, from B to C, from C to D, and D to end. So A, B, C, D, end is a path. That's path number 1. Then I have another path, A to E, E to F, F to H, and H to end. So A, E, F, H, end is another path. This way, if we find out how many paths we have, we can actually find out total 4 paths in this network diagram. The only rule you have to follow is just simply go by the direction of arrows. Do not go in the reverse direction of the arrows. Just simply follow the direction of the arrows to find out how many paths we have in the network diagram. Please take a look. Let me know if you can identify the paths. You have any questions? Now, my next step would be to identify the duration of the paths. Very, very simple. Simply take the summation of the activities on that path. For example, A, B, C, D, end. So that is 4 plus 4 plus 4 plus 2. that's 14 weeks. AEFH end, that's 4 plus 6 plus 6 plus 4, that is 20 weeks. This way, if you calculate the duration of the 4 parts, you would see this path A, B, C, F, H, end has the longest duration of 22 weeks. The path that is shown with the red arrows in the diagram, that has the longest duration in the project. That duration is the critical path. Yes, Gonzalez, that's the definition of critical path in a simpler way. We can say it is the path which has the longest duration in the project. So what can be said now from this diagram? We can say that A, B, C, F, H, end, this particular path has the longest duration of 22 weeks within the project, and this is called the critical path of the project. Hi Wilson, see, the definition of a dummy path is different. Dummy path is used only for activity on arrow diagrams, which was a topic in version 4.0. We are no longer using a concept of dummy path in version 5. We are discussing precedence diagrammic method. In other words, it's called the activity on node diagrammic method, wherein the activities are represented with boxes and the arrows are used to show the dependencies. There is another diagrammic method which is called an activity on arrow diagrammic method. For example, I would represent AB as an activity and I would use nodes to connect them. There, sometimes I use a dotted line to show the dependency between two activities. For example, in the diagram I just drew, I have activity AB and I have activity CD, and then I have a dummy path which shows the dependency between activity AB and CD. That's entirely different. That's a separate diagrammic method which was a concept of version 4 and it's no longer used in version 5. Don't consider that. We are talking about precedence diagrammic method or activity on node diagrammic method. We do not have a concept of dummy path here. We have taken a dummy node in this case which does not have any duration. I have just used this node to complete this diagram, to close it. That's all. Yeah, I'm coming to that, Ramesh, why it is called the critical path. The reason, can you guess actually why it is called the critical path? Any idea? Ramesh has actually dropped a question. Why the longest duration of the project is called the critical path? From this diagram, can I say that this activity, this path, A, B, C, F, H, end, all the activities on this particular path are actually happening in sequence, and that indicates the total duration of the project, which is 22 weeks. I can actually say the critical path signifies or indicates the total duration of the project, and all the other activities which are not on the critical path are happening parallelly within that 22 weeks itself. I repeat myself again. I can say that activity A, B, C, F, H, N takes the longest duration in the project. Hence, this path signifies the total project duration of 22 weeks, and the other activities like D, G, E, etc., they are happening in parallel with the activities on the critical path. So simple words, I can say that the critical path indicates the total duration of the project. If there is a question in the exam asking you that the duration of a critical path is 20 weeks, what is the duration of the project? The answer is 20 weeks. Critical path indicates the duration of the project. And most importantly, why it is called critical? You have to monitor all the activities on the critical path very closely. If one activity is delayed by even a single day, the entire project would be delayed by that much duration. See, activity E, G, D are happening in parallel. So even if I delay them, that might or might not have any impact on the project. But if any activity on the critical path is delayed, that would definitely impact the schedule of the entire project. Right? That's why it is critical for the project management team to closely manage the activities on the critical path. And other words, we can say that is the reason this path is called the critical path. Okay? Any question, guys? Now let's another concept of float is involved in this particular concept that I need to describe. If I go back few slides, this is the definition of float. Total float is a difference between early and late dates. It indicates the schedule flexibility, and free float is a time by which an activity can be delayed without delaying the early start date of an immediate successor activity. Now let me go back to the example once again. We are saying that there are two things here. Total float, another name for the word float is slack. Total float indicates the total flexibility within the project schedule. So for example, your customer has asked you to complete the project within 40 weeks, and you are actually completing the project within 22 weeks. That means you actually have a buffer of 18 weeks. This is your total float. Total float compares the actual project duration with an externally imposed due date. So we can say that float is nothing but the schedule flexibility that you have. And then we have another concept of free float. What is this? Free float is the amount of time, the duration by which you can delay one activity without delaying the entire project or the immediate next activity. For example, the duration of A, B, C, D end is 14 weeks. A, B, and C are on critical path anyways. I cannot delay them. But if I delay activity D by, let's say, 8 weeks, up to 8 weeks, what would happen? The duration of this path would now become 22 weeks. But still, the project would be completed within 22 weeks. My project is not getting delayed. Please follow me very closely. What I'm saying is, as the duration of A, B, C, D end is 14 weeks, and A, B, C are already on the critical path, I have a flexibility on activity D that even if I delay that activity by 8 weeks, up to 8 weeks, it does not impact the overall project schedule. So that indicates the flexibility on a particular activity that I have. That is free float for activity D. Similarly, you would see that if I delay activity E or activity G by up to 2 weeks, okay, because these paths are 20 weeks and critical path is 22 weeks. So if I delay activity E or activity G by up to 2 weeks, there is no impact on the project schedule. The only thing is that we will have multiple critical paths, because the second and third path would also become critical path. But overall, there is no impact on the project schedule. So that indicates that I have a free float of 2 weeks on activity E and G, and a free float of 8 weeks on activity D. This is the concept of float, which indicates the schedule flexibility. We just talked about two different type of floats: total float and free float. Just to give you a little bit more insight from exam point of view, as we said that the critical path, activities on the critical path, if they are delayed by even a single day, that would impact the overall duration of the project. We can say that there, the float on critical path is 0. There is no flexibility available on the activities on the critical path, right? No, if you delay activity, I'm sorry, can't, if I name if I pronounce your name correctly, is it Gada Sams? See, if I delay activity E or activity G by 2 weeks, what would happen to this path? This should become 22 weeks. If I delay activity G or H by 2 weeks, this should also become 22 weeks. So it doesn't become 24 weeks. Please do the calculation and you would understand that. And more importantly, yeah, it is either or. When you actually calculate float, you should actually, you will actually need to consider only for one particular activity, keeping the others at their baseline value. Okay, do not consider the other, couple of activities together. Consider for one activity at a time. One more thing that I wanted to say is on the same question that is raised by Ramesh, that is, yes, if you have multiple critical paths in a project schedule, that means you have to monitor more than one schedule at a time, more than one path at a time. So that would actually prolong your or increase the risk of your project. We are saying that you have to closely monitor the critical path, but if this path also becomes a critical path, that means now I have to monitor this and this, two paths simultaneously. So this actually increases the risk for my project, that now I have two critical paths to monitor. Any of the path gets delayed, my project would be delayed. Okay. In case you have a complex network diagram in the exam and you're asked to consider the float of a particular activity, you normally use the concept of a forward pass method or a backward pass method to calculate the float. Okay. Due to time constraint, I would not be able to explain the forward pass and backward pass method in details. Okay. But just to let you know that we have a formula to calculate the float, that is late start minus early start and late finish minus early finish. Either of these formulas would give you the float for a particular activity. How is this calculated? It's a time consuming matter. I cannot cover it within this particular webinar. Maybe you can follow a handbook to find out what is forward pass and backward pass method and how exactly you can calculate float using that method. But trust me, in the exam, you would not get a very complex diagram asking you to calculate float. You would get something like this. And it is easy to calculate float with the help of a diagram like this. Because I just said that consider a path A, E, F, H, and in this path, A, F, R, and H, these three are uh, part of the critical path, so they have zero float. But E is not part of the critical path, so it would have some float. Now simply take the difference between this and this, so you would find the float of activity E. But yes, the bookish method of finding out float is using the forward pass and backward pass method, which you should take a look from a handbook or join another webinar or another session from WizLabs to understand it better. Hope this helps you to understand the schedule and how it is calculated. I must say that scheduling is a very important topic from exam point of view, and it requires much more discussion. We need at least a couple of hours time to first understand the work breakdown structure and then get into the scheduling part so that we can actually understand the entire concept of how scheduling goes. Most importantly, scope, cost, and time, these three are considered as a triple constraint of project management, and they're closely interrelated. If I do not explain scope and time in a detailed way, I cannot actually talk about schedule management, in a very clear way. But anyways, hope I was able to give you the overview of why scheduling is important, how we create a network diagram, how exactly we calculate the critical path. This should definitely help you answer at least 5 questions in the exam. Okay, if you don't have any further question from this particular topic, this is the end of today's webinar, guys. Just to reiterate, this is a demo of how exactly do we conduct the real online training programs. WizLabs keeps conducting the 4 days training programs for a small batch of 6 to 8 participants, not more than that, wherein we go through this similar concept of GoToMeeting, and we use the same audio and video bridge. We use the screen sharing to cover the entire PMBOK topic. It's conducted during the Saturdays and Sundays to cover all the topics related to PMBOK, and along with that you also get the 1,000 questions related to PMP, which helps you actually coming up with preparation for the test. Okay.